So, some of you already know my project, and many of you are new. So, like the premise for my project is that right now, when we use group messaging, like I've studied about how it works, and it is not completely secure. So, there is something called messaging layer security, and they are the team who are trying to build a standard for group messaging. Right now, the infrastructure they have developed, it is dependent upon a third party which updates the group key regularly. And I found did some research and found something like I can implement a framework which can reduce the dependency on the third party. So how it will work and what are the like prospects of the project, I'm just gonna show you. So uh, yeah, so this is the research paper that was published this March. It is about designing a key lattice framework for concurrent group messaging. So like there is a lot of content. So the basic premise is that instead of depending upon this infrastructure provided by the third party, we create an infrastructure that is dependent upon the number of participants, and they can individually have their freedom to update the group key, and that will maintain the group key. Like it will change the group key, but we don't have to depend upon any other third party which will update the keys on based on time epochs. So I have a flow of how this will work. First I'll show what the problems are. So I chose two example of Signal and WhatsApp. So like in Signal we have something called client side fan out. So the thing, okay, so this is a basic working of how Signal works. So if I'm a person who wants to send the message to the group, I have to encrypt it for everyone. This will be another some encryption, this will be some, this will be, and this way I have to make n number of encryptions for n participants, and that is the scaling problem, because as a client I have to make a lot of encryptions which is not like feasible for large groups. So this is called client side fan out. And then this is the example of how WhatsApp works. So in WhatsApp we trust a third party which will encrypt our message for every member, and then it will like send the messages. So here is the issue of trust dependency. So these are the problems. Like there are other problems with other protocols. I just took the example of two. So this is a basic flow of how the protocol, like the messaging protocol, will work. So first, like normally how it happens, that first every member of the group, they agree on a group key, and then we start the group chat. So when we initialize the group messaging, we actually initialize the group key agreement which will send the messages. There will be some transfer of message within each member, and finally they agree on a group key. And then like I'm not focusing on the group key agreement because they already exist and they are a standard. So after agreeing on the group key, we initialize the lattice. So we initialize the lattice with the point origin and the key we have agreed upon, and then the group randomized execution will be initialized, and there will be a buffer which I'll explain why. So now when we have initialized the lattice, after that every member, like if there are n members, so we have n dimensions, so every member in their dimension can update the group key depending upon what they want, how they want to. So there is a proper message how they will upgrade. So say I am a person in my dimension, I just updated the key. So D will signify what my dimension is, J will signify how many times I updated the key in my dimension, and X is the data, the random data I sampled, which will be helpful in updating the key. So how a lattice works, it's actually like so if this is a lattice, or maybe if I have a two-dimensional lattice, this is 0 0, this is 1 0, this is 2 0, 0 1, 1 1, and 2 1. So from moving from one point to another, there is an edge which specifies what data I need to move to the another point. So in this way, if there are two members, they can update the message in their dimension, and like this data is necessary. So for an adversary, if he wants to actually catch the group keys, he has to know the edge data as well as the vertex. So that is one thing we are benefiting from. And then we have something called a forget function. So the point of this function is that when we keep updating the keys, say I've updated n number of times, so it is not feasible for every member of the group to store all the keys. So there is something, this is the w parameter. So the w is the parameter. Say w is like for window. So if I have window of this to this, so these are the keys that I don't need because they are already being upgraded and they're not being used. So in this way, the initial key we agreed upon, it is forward secure because no one has the path to go back to the initial key, and this is the w parameter. So we are solving the size problem that we don't have to store a lot of keys. So yeah, this is the working, and this is the like functioning of the encryption that happens. So I'll take a message, I'll use AEAD to encrypt the message, I'll return the ciphertext. Like this is for the normal messaging of the, like the normal messaging that we do, the normal encryption and decryption. And yeah, I have the working for the lattice too. So like K is the space of keys from where we'll generate the key. L will be the lattice. The key lattice actually is a set of pairs. So we have a coordinate and we have a key related to it. So that's how the lattice will work. Then we have some functions which will be helpful in updating the keys. So we'll use the key roll function, which will take some data. Like it will take the data from the update space, it will and use the previous key, and then it will generate a new key. So like it should be commutative and unpredictable. It should be also one way. And this is the definition of the key graph, how it works. I have already explained that. And this is the manipulation part. So in manipulation, what actually it is. So like this is the tuple that I, after updating my key, I'll send to every member, and they will use this tuple to reach to the point I have updated my key in my dimension. This is the data that I'll send. So there will be actually two messaging. One will be the protocol message will be sent to everyone how to update the keys, and the other will be the random group messaging. Say I say hello to everyone, so it is encryption and decryption. And this is the setup. So like we initialize at 0, k naught, then we update, then we send the application message, how the decryption happens, and the managing key, which is actually the forgetting key parts. I wrote some code actually. So this is the, sorry. Sorry?
Maybe light version?
I'm not sure. Is it visible? I'm not sure. Okay. I'll just increase the size. I think it should be. So this is the code for like random messaging. This is the code for group key agreement, which is like very basic. This is for random messaging, where like I'm trying it for 3 members right now. So I have the key lattice, I initialize it, like I have a init function. Then there are some more functions for getting the maximum key in each dimension, then the add key function, then the update max index. This is the very basic key roll function. I just used a hash library right now, but after like checking the security considerations, I'll update it. And there's an increment function, and this is the participant class. So as a participant, what all functions do I have? So I initialize it, then I can send the update to another member. Then this is a like secure send. So we like when we are in the group, we have a secure pairwise channel for sending the group key updates. Receive secure for receiving the message, for the updating the key, for I didn't explain the buffered. So the buffered is, say I have sent you hello, but you have not received the message for updating the keys. So then the hello will be placed in the buffer, and after I update the keys, you'll like process the buffer message and decrypt the message. Then there's a send message and a receive message. Then we decrypt the buffered message, and then there's a forget function. Like right now it's very basic. I will have to update that, but yeah, this is what I'm working upon. Yeah. Thank you. And any questions? Yes.
Can you run the code? Sorry.
I like it. It compiles. Yeah, it compiles, but I can't show you how. Yeah.
Yeah, what's this one? And can you also please
Yeah, it compiles actually.
and can you also say like what is your struggles on the project?
Yeah, so like
What do you feel more comfortable?
the comfortable part is that I don't have to write the code for initial group key agreement, because like there is a protocol CGKA, continuous group key agreement, which a lot of people have implemented, so I don't have issue there. But I'm like, this is what I am trying to implement. But if someone is like very good with data structures, he might have a clue about how we can implement it more efficiently. Like this is the very basic version, but for optimization or for making it more secure, which libraries should I use? So I'm open for recommendations. Yeah.
Is this lattice like functional? Like, can you compute the key given at 00 and call it that?
Yeah, the how it works. So like this is the origin, and this is the k naught key which I've agreed upon. So like if me, you, and he is talking, so this will be a three-dimensional lattice, like n members, so n dimensions. So in my, if this is x, this is my dimension. So this is the edge data that I'll provide. Then there is a computable function, and there is a update function. So update function will actually update the keys in my dimension, and I'll send this data to you through a secure pairwise channel. Then you can use that data to move to this point in, like you are in y, but you have to go to this point, so you will need this data as well. So like you updated here, but you need to go here. How will you get this data, which I'll provide to you, so you can reach here? So this is how you can move the keys, and it is like concurrent, because you're not dependent. Like if I'm updating, then you don't have to update or something. That is independent. So like we are creating n degrees of freedom, and everyone can update in their time. And actually we should automate it, because we don't want any user to regularly update. We can automate that. Yeah.
So, sorry, I confirm missed that. So, when does this moving on this lattice happen?
The update.
Yes.
Yeah, so yeah, actually the update, so right now I have to like call the function for the update, but we can automatically like automate it when the user wants to update. Maybe we can.
What I mean is, what triggers?
What triggers?
Yes.
Yeah, that is random.
Oh, it's a random.
Yeah, it's random. Like
And it's monotone?
monotonous in the sense,
In this
is
direction, so we have
like this.
move up and right.
You will move in your dimension. It's monotonous in your dimension, but you have the data for other dimensions. So in that, like if I'm in x and you are in y, you will provide me the data for the y dimension. I can move there in the y dimension, and I can move it.
Okay.
Yeah.
What exactly is this key? Like, is this the key that the group messages are?
Yes.
But if the key changes, how will you read the old messages?
No, yeah, that's why. So that's why we have created a window parameter. So like we like how do you say, we optimize the window parameter in such a way that only after those keys are not, like those keys are redundant, we run the forget function, so that we don't have to store those keys. And you will store some window of keys, so I can encrypt with any key, and since you have stored this window, you can decrypt it. Yeah. Okay. Thank you. Sorry.
Who is functor? Me? I'm here. Oh, okay.
Oh yeah.
Scusi,
Oh,
would you mind?
absolutely.
You can leave a gift here as well.
Here?
Oh, you can put it here. Excuse me.
Of course. Like this? Okay, cool. Awesome. So let me connect my screen. Does this work? It should work. I had an issue with this connection because it's not working properly, so if it's not, then can I send this to someone else's computer?
Try to use a function. I thought that was like a.
No, it's that water went through this,
Oh,
so sometimes works, sometimes doesn't.
you have another option?
No, maybe the next person can present me while I fix the presentation issues.
Can we switch and go to the
changing laptop?
Probably, but so we don't lose time.
Okay, who is Massini? Okay,
Okay, cool. I'll figure out how to send it to someone else.
you can send to me.
Yeah, I was in two. Sure.
Thank you. Here's the microphone there.
Oh,
Or you can take out the main. Want some help? Let me see if we do not turn off the microphone.
okay.
You had AG straight, right?
Yes.
Yes, alright.
Thank you. Vale.
No, it's sent to me because I need to. Yeah.
It doesn't work.
So display settings.
Yes, it's here in this place, but it is not detecting it. We can try with the USB-C.
USB-C is there.
Ah, okay.
Where?
No, this one.
Ah, okay. Thanks.
Yes, it works now.
Yeah, here we go.
Okay. Okay, we are the Massini team. We have been checking out which projects we could do. We usually work with DAOs and with governance. And in the context of Invisible Garden, we wanted to work on privacy on boats. So the first thing that we knew about the people who is around here is that they PSE basically have this Macy protocol, and we decided to go further and understand how it works and how could it would be adapted into in first place a governor like Open Zeppelin governor, but also on other ways in which you could maybe allocate budgets among people based on the amount of votes that each project have. So the first thing that we did was to go through the documentation. Wait a sec, I can show. Well, actually, this is the one of the front ends of Macy. It's not the most official one. It's what's called Macy Wrapper. And this is the base that we are going to use in order to move forward because it has a lot of features like creating the poll and things that
usually with Macie you have to do using the CLI. We are focusing the project on making Macie usable, and one of the most first things that we want to fix on Macie usability is the fact that in order to tally the votes, you have to do a lot of command line stuff that I can show actually, because I have been testing. Let me see if I have. So basically you have to use the command line all the time in order to create votes, or not for voting, but for creating polls, or deploying the contracts is fine, but for creating a poll or to count all the votes and produce the result, it should not be the case. So what we have seen is that you need to generate the proof, and there are some WASM programs that you have to run in order to do that. And since WASM, WebAssembly, is something that you can run in the front end, our first step will be that to run these WASMs instead of the console in a front end in which you just say, okay, this is my poll. I want to grab all the data from the blockchain and generate the result. So this is our first step, and later on, a more broad, it's still very early for us in order to know exactly which is going to be the final result of our project. We intend to do a front end that is easy for everyone to use, using the official Macie contracts, but we are still early. And in case that we accomplish to do Macie more usable, we could integrate it into Council House, which is another project of us that is used to allocate budget, and it will fit pretty well. I don't know if there is any question, we will reply them, and otherwise I can show a little bit what we would like to do, but maybe we don't have time during the Invisible Garden. Any question?
Is this kind of a SDK for any firm or any repo to use? That you're creating an SDK that if I want to implement in my protocol, I can use it for private.
Macie, as it is written right now, it's a set of ZK proofs and a set of smart contracts that you can use in order to make collusion of voters very difficult. So it actually protects privacy of voters when they are voting for something, for a result, right? It's actually a kind of SDK as well, because it has a CLI and it has a lot of things. But as it is right now, we just arrived and we don't know a lot about Macie, and we are still investigating and researching about that. But to our understanding, it's a nice library that needs a lot of work in order to make a product out of it, and it's already been used in different places like this. I heard that Vitalik was using it in order to spread, to allocate budget, and there are other things that are using it in order to do quadratic voting with. But what we found is that it's very difficult to tally the votes, and it's the first thing that we want to fix.
I think he was also asking if it's like a front end that you want to build to make it more simple,
Yes.
or is it just an SDK for developers to use?
We will work on a front end, but it could also, what we are looking for is to build a front end. SDK would be a nice thing. I think that SDK should be something that is integrated within Macie, not the front end that we want to. We are not as ¿cómo se llama cuando? Sorry. we are still starting, so we do not want to be very. We want to make something that is very useful and it's easy for us to build, instead of trying to do something that it's very big and then it ends up on nothing. So an SDK is out of the roadmap for us. Okay. Thank you. We tested Macie platform, and we saw that it is limited in the terms of it's a front end that you set up when you already have a vote running. It's not in order to create votes or something like that. It's more like, okay, here is the place that people can vote. And also for tallying the votes, it's not, there is no front end or anything that you can use. I think that if there is something, then we stop working. But I think for tallying the votes, there is no front end.
Yes, we actually also worked on the base. They actually worked on a very similar application within Hackathon. But we didn't go as far because the tallying and all that actually requires, to take some time in the background. So we were hoping to have a nice application that runs the entire process, but we weren't able to get it done within like 2 days. So I think we can talk later about.
Okay, perfect. Yes.
It's like a super fast integration for because we found out that actually if you want voting, the CK identity, or having an identity is very important also. But we can talk about later.
Okay, is it a gatekeeper? Did you write a gatekeeper for Supas?
Yeah.
Okay. And did you do the tally thing as well?
Not the front end.
Okay. Okay, thank you. In the which ETH Global was it? It was ETH Online? Singapore. Singapore. Okay.
I've linked the projects on the Excel.
Excuse me?
I've linked the projects on Excel sheets.
Okay. Okay. Then I look for you then. Okay. I think that this is it. Thank you very much.
The Macie platform.
Yes.
It's called.
Yes.
Yeah, it's like also actually a kind of project that manages private votings. Yeah. You see already like
It's the one that I was talking about. It doesn't have a lot of
this.
all the features.
Okay.
It only has the voting part, but not the tallying part.
Okay.
Thank you.
Your phone? Is it your phone?
No. I don't know who.
Don't forget.